For the Legacy Series, I'm Jeff Nally with Dr. Fred Whitford, and today we're talking about it's a pitting shame. Must be something about storage tanks.
Well, exactly what it is. It has to do with one of the tanks that we use, mild steel, and the pits and corrosion and those kind of things. Jeff, you know there's all kind of tanks out there, right? There's we got poly tanks, fiberglass tank, mild steel, and stainless. And each one of those have got positive and negatives with it.
Some of those easier to tell how they're weathering use and how they're holding up over a period of time. Sometimes it's not so easy to see from the outside what's going on the inside of the tank, but it's all about environmental responsibility and management of making sure that what's put in the tank stays in the tank until it's time to come out and use the way you want.
Yes, environmental and from just economic. We can't afford to have a spill, a leak, a tank that breaks, environmental issues, government sanctions, fines, cleanups, and all that. So it's to our advantage to do a little bit of checking on before we buy a tank, but also doing the maintenance work.
So in this video, we're going to take a look obviously at mild steel and stainless steel. We're going to talk about the advantages of both, maybe some of the points that you want to bring out about it.
Yep.
And it's all about, again, maintaining and being operative of knowing what you have and how to make the most of it.
That you got it. All right, let's take a look at it. And like I said, this one, we're going to focus on the two steel tanks.
Okay.
So mild and stainless. And we're going to start off with mild. Mild's a very common steel that we use. As you can see here, some of the positive things to it. Long-lasting, durable, typically less expensive than stainless, sometimes by a lot. I can fix them, I can paint them, put logos on them. And one of the advantages of the mild steel is that when they leak, they just don't burst. They seep. Okay, so that's a huge advantage. We have a time to watch them leaking and fixing them.
Of course, if you had a poly tank or a fiberglass or other that it was penetrated or it burst open, yes, that's a much different situation than what might be we consider maybe even a slow leak,
right,
with one of these.
Slow leak's a good example. So a poly tank doesn't have a slow leak; it ruptures. A fiberglass will act more like this. It has a seep. It seeps through. Okay, so the downside, and it's a big downside, that like any product, there's conditions that will rust. You can see it on the outside, you can see it on the inside, but it's this pitting where these the fertilizers is the best example.
The corrosive nature
it's
of the
corrosive
product.
nature of it, and it eats in the side of the walls, and it tries to find a weak spot in the tank, and it starts basically just pitting, what we call pitting, as it eats the metal. And obviously those become weak spots in the steel itself.
And places where you're vulnerable.
And you're vulnerable. And so another downside are the weights and transportation cost. You know, they're pretty expensive kinds of products just to have to ship them to us. So when we look at them, and we've all been through it, we have to replace certain tanks and we have to buy them. You know, we always have to be mindful about the size of them, putting them into containment, making sure they can fit. You say, well, who would order something that wouldn't fit? Happens all the time. It happens all the time whenever we try to put these on the inside, and we forget, for instance, when the door slides across, that sometimes these tanks are too large where that door can't slide, and that creates another set of problems.
So measure twice.
The measurement twice.
Measure twice and order once.
That's correct.
There we go.
But the main thing about the mild steel is that they do rust.
This is just really disappointing because you know they don't last forever, but you don't want to get to a situation like this. My question would be, what was going on before you got to this situation?
Well, and that's what we're going to focus on here as we go through here. And obviously these rust flakes that we have, not only is it showing that the tank, the bottom or the sides, or if it's this is a storage tank, but if it's a tender truck, let's say, that I surely don't want all these flakes of rust in there going into my $450,000 sprayer and then stopping up the nozzles and causing a problem. So this is the issue with these mild steel tanks. Now this is an external shot of a tank, and Jeff, you can see the pitting. And on this particular one, I believe this is the one I took. This was actually a fuel tank, And it's the same thing, they're all mild steel. We've all seen fuel tanks when you drive around. Some of them are well taken care of with paint, and then other ones are just left to rust. And you can see here it's starting to pit. And now, again, this is just part of the rust. We see this out there on the big tanks. You can see where the water runs. This is just rust. We all know that rust breaks down, is a function of breaking down the metal.
The mild steel is going to be welded together, maybe bolted together. We have to watch pitting and the masked face of the steel, but you also have to keep a close eye on the welds.
That's correct. And here you're seeing most of what I'm familiar with on a mild steel, most of the leaks you're going to have are going to come through the welds.
So we keep an eye on those closely, and of course this Trail of Tears here is one not to forget.
Actually, not a bad analogy. How'd you say, Trail of Tears?
Trail of Tears, yeah,
And
that means I'm going to have to spend money.
Yeah, somebody's, this is crying here, but it also tells us that something is going on the inside too. Mm-hmm. All right, so this reaction that we're seeing is inside and outside, and if you looked on this one, it may not be as obvious until we point it out, but you can see above this weld here, can you see this crack?
Yes.
Okay, now, again, I would see that on the outside when it came through. The good news is it's going to seep. It's not going to just break, but this is what's happening on the inside. It's corrosive. Now, we have to be real careful when we buy a tank. And if you notice on the outside of this tank, can you see that full weld across it?
It's a solid bead all the way across. It covers up the crack.
Yes. Now let's look in this tank here. On the inside, what do you notice?
Spot weld.
Yes. So it's staying together, ain't it?
So instead of having two welds that's sealing that crack, I only have the exterior weld.
Because right in here are places for this fertilizer to get in, to settle in, and begin the process of basically tearing up the mild steel.
And if I keep that tank full or operable throughout the year, seldom if ever am I going to be in there to see that until I get the trail or the seep that is indicative of a problem.
That's correct. Now, some of these tanks will look good on the outside, and you can see I just took this knife and you could just jab it right on in there. I mean, this thing was just ready to fall apart. So how long does it take? Oh, it may take 15, 20, 30 years. Nobody can tell you that, but eventually these tanks do wear out. And what we're trying to do is to keep them in production as long as we can. So Jeff, what we've got here, we're going to take you inside of a tank. This was a fertilizer tank that we had in Indiana up north. When it gets cold, a lot of this stuff will settle out, and if you've ever cleaned out a tank, you always have a layer of scum on the bottom. And so what we're doing here is we're going to be looking for how bad the pitting is. Mm-hmm. So this was an opportunity when they had emptied the tank. They're going to put all of this stuff in solution, pump it out, and then what we're going to just do then is get the rest of it to clean it. And what we're going to look for is now the pitting. And just in case it's hard to see, this is actually a pit, not
crater.
It's a crater. It's a crater.
Crater that's dug down. So we're watching the wells. We're looking for that Trail of Tears, that seep that's coming. We're also now looking for pitting. And if you don't have a habit of getting inside the tank, of having the clean out, then you're operating with an unknown, and there can be some tremendous issues that can develop from that. So it'd be good to be able to see some of this up close.
You betcha. So that's what we're going to do now, Jeff. We're going to go out there and look at some of the tools that we have that allow us to see how deep the pits are, and if I can't get inside, how we're able to see is there any deterioration in the thickness of the walls on the tank. So let's go on out to the field and put this stuff to use. Mike, good to see you again, buddy.
Good to see you too, Fred. How are you?
We're doing good.
Good.
Again, I really appreciate you letting us come here to the facility. So, Mike,
No problem.
Tell me what you do for Co-Alliance.
Well, Fred, I'm a risk coordinator for Co-Alliance LLP, and we do a number of things within our department. We do some training, we do regulatory compliance, and we do some emergency response. But the big job for our department is to make sure that our plants are running smoothly and safely, and that we're treating our partners within the community in a good way.
You betcha.
So keeping them safe as well.
You betcha. So, which brings us here to this facility. So we got a tank that's going to be coming out of service.
Yes.
But what's really nice, this is like I said, a couple of decades old, and it's a good way to see what happens toward the end of a tank's life.
Sure.
But more importantly, you can see some of the decisions on whether you replace a tank or not, because I know these things are expensive, but they do have a finite life.
Yes.
So this is a mild steel tank, and as I was looking around the outside, Mike, I noticed what looked like somebody tried to make or did make a repair here.
Yes. Sometimes in the older tanks, we would find seeps. Maybe they were more prevalent in a seam in the weld, and in this particular case, we had a problem right here, and so we made a decision to weld that up, and it's done well. It's held for a long time. This tank has been good to us.
You bet. Now, a couple days ago, one of the guys was doing their regular daily maintenance inspection, and what did they find?
Well, as they were walking around doing their visual inspection, they're looking for seeps, they're looking for places that come out of a pit maybe or whatever and has seeped a little bit. But in this case, over underneath the manway, they found a place where it had seeped down into the stone, and there's obviously a leak right there, and so we took it out of service and pumped it out.
Okay. Now, if it hadn't been for that, Mike, and we had another leak somewhere else, that would have been necessary for us to probably go inside to evaluate the inside.
Yes, that's probably what we'll need to do, and to get a good picture of this tank.
So it's two observations. So one is going to be this external observation.
Yes.
Now, this material that we kept in here, Mike, is 28.
Yes.
And you took some reading on the pH, the acidity of it. What did you come up with?
We came up with a 3 or 4 pH on this product, and that it probably didn't surprise me, but that's kind of what we've been seeing. The trend in recent years is that the 28 has been more acidic.
But you and I both know that acidic materials, real acidic materials,
it's going to be hard on this tank.
It's going to make these tanks make it harder on the
Yes.
tanks, because that's what helps with the corrosion, right?
That's exactly right.
All right. So let's do a couple of things. Let's assume that this tank was full. We have to make a decision on this tank. There's something that we can actually use on the outside
Yes.
instead of going on the inside. Mike,
I have a
is that right?
couple tools that we use, and one of them is this ultrasound. It's a what we call our thickness tester. It's a very simple device, and so we can turn it on. It can either read millimeters or thousandths of an inch.
Okay.
Okay, and we have zeros there, so we're going to, if I could get you to hold this just a second, this part of it. When I get ready to use this, I want to do a calibration test just to make sure that the instrument is working correctly.
And these are known thickness?
These are a known thickness,
Okay.
okay? They're a certified thickness.
Okay.
And so the calibration bar comes with a kit, and so we put a little bit of a jelly on there to make good contact, and I'll kind of put it down on there like that, and we should have something in the 500 thousandths range.
0.5?
0.5.
Okay.
Okay, so that's what we're looking
That's
for.
0.5 of an inch.
Yep.
Okay. So
it's 500 thousandths.
Okay.
Yeah, yep.
Okay,
Or
so
half an inch.
Half an inch. So we're in good shape
We're in good shape. It's reading close to where it should be.
now.
And so we might take and we're going to look at this tank. Now there's a couple things about this. We have some paint on it, and if it has zinc in the paint, it will read that as a metal as well.
Okay.
If we have a layer of corrosion or flaking metal on the inside, it will read that as well. So as I go around here, it may show good readings, but I may be missing pits. I mean, there's no way to know what it's going to look like in the inside.
It's
So
one
a tool,
it's one indicator.
It's one tool that I'm going to use to help make my decision.
All right, so we've got a repair, and now we're going to look at the thickness of the tank, and has this corrosive material eaten some
Yes.
of the material.
So we'll take this, we put a little bit of the material on there, we're going to get a good seal, and we get it on there, and what kind of reading we have?
I'm getting 0.33.
Okay, so that's a little greater than the 1/4 of an inch that we
Yep.
were looking for. But again, if there's some scale in there, I have my paint, that does not surprise me. But what it tells me is that I'm not on top of a pit either, or an
Okay.
area where we have a lot of corrosion on the backside.
Can we try one more down
Yes.
lower? Because I'm thinking maybe
Let's do that.
see if we have anything down low.
So I'll bend down here. What do you have?
It dropped down to 0.26.
0.26.
But it's still a 1/4 inch tank.
Yes.
Okay.
Supposed to be. That's
Okay.
what the manufacturer specs were on this particular
So
tank.
based on that, it looks like from the external, it looks, Mike, like the tank has still
Yeah.
got its integrity.
From that alone, I'm thinking this is a pretty good tank.
That's correct. All right, now, so you know the only way to do this is to do what?
Next step would be to get inside, Fred,
You
and
know-
take a look.
And I've been looking forward to that, Mike. Let's get in there and see what we can see.
You're looking forward to it more than I am.
All right. Well, Mike, we're inside this tank here, and nothing really exciting. There's nothing that there's nothing unusual here. I mean, in terms of this is what it looks like, and
correct.
you can see up and down. I'm seeing material that dried up fertilizer, and we can actually see some of the metal. And you know, in lots of these places, you know, it looks like the metal's pretty good, doesn't it?
Except, like here, you had a place, and then if you kind of pick there a little bit, you are going to start to see a small pit.
Yeah, and that is the pit, and that's what
Just
it's just starting. So we still got some liquid down here, but what I want we could do here, Mike, is if I see some of these piles of stuff here, and if you can pick up a pile, let's take a look at it. Just go ahead and pick it up, and if you can bring it over here and let me see what we got here. And so it looks like it's probably what, half dozen different things, rust?
Yeah, there's some rust in here. There's probably some byproduct from the manufacturing of the material, but you see a lot of chunks right here. That's erosion from the container itself.
Okay.
And this is normal that we would find in here.
And this is why we'd like to check these tanks every 3 years or whenever
It's a given.
to be able to wash this stuff out, because that's the last thing I need in my sprayers.
Yes, sir.
Okay, so we have some corrosion on the bottom here. And Mike, the concern that we have is this is a 1/4 inch thick, is that correct?
That's correct.
So what we're worried about is how much of that wall is actually corroded of that thickness. And we actually have a way of measuring this, because a person would come in here and say, oh man, this looks bad. Well, it doesn't look bad. It looks like inside of a fertilizer tank. But there is an important thing, and you've got some marked here, I think, right?
Yes. This was a spot that we identified that we wanted to look at just a little bit, and we could probably go a little farther. There's probably multiple places like this. This actually is kind of somewhat in a weld. Okay. Can I borrow your ink pen, please?
Yeah.
Okay.
There you go.
So this is in a weld, but we have it had been repaired, okay, on the outside. So we're looking at this and we're saying, well, you know, what's going on here? Is it worse, better, it's the same, or whatever? And so one of the things that I noticed when I first walked into this tank was this. And we see that on the outside of the tanks too.
It almost looks like it's bleeding.
It's kind of working out of there, and we'll see that on the outside as well. I can take my pick gauge, which we're going to use as a tool today to try to make a decision on what we would do with this tank. And this pick gauge has a very narrow needle on it. It's on a pendulum, so it will move up and down on a scale.
And that's the part right here that I'm going to stick into the hole, the
That is
bit.
the part right here. And it has we read it in thousands for a real precision type, the best you could do with an instrument like this, or we'll read in inches. For me today, making this decision, knowing that it's a 1/4 inch tank, if I have anything over 1/8 of an inch, then I'm probably, that's a negative for this tank. And so we would take the pick gauge up, we could put it in here. I found a place that I identified that I wanted, that I had a
Hold it
concern.
right here. We could see the bit, Mike. I'll hold it. And that's what you're talking about, that piece of metal.
It is right here that I had a concern with. We could have checked anywhere, but this appeared to be the deepest.
Okay. And what was our reading?
We're about 1/8 of an inch.
Out of a 1/4 inch.
Out of a 1/4 of an inch.
And that's
So I don't really care about the thousandths in this case. I already know that this is 50% of the erosion in this spot.
And Mike, different companies probably use different values, but whatever it is, but 50% for me says, at least on that one spot, half my wall is already corroded.
When I find a spot like this in a tank like this that I know is already leaking in another spot, has leaked here, and we've done a weld repair at some point, there's probably hundreds or thousands of them in here that are getting like this one.
So it's not a spot, but we're worried about thousands.
We're just taking a snapshot
Sure.
of what might be going on within this
Well,
tank.
let's, Mike, we have another spot that we've identified to your right there. And if you'll tell me what you see there, and again, it's similar to here, but
Yes.
what do you see there?
Well, this one here has been a weld as well. Again, when I walked in, I took a quick glance around the tank, and yes, you can almost look around and see those all the way around.
Yeah.
But this one here interested me especially because it had some very, very heavy corrosion. And again, this is a weld right here that we're going to, that we've had some issues with. I look at it and just observe it, give it a quick assessment, and right here appears to be my deepest point. And so we'll take the pit gauge and we'll put on there and we'll try to get the best sample reading we can. And again, that's another area right here.
What did that one read, Mike?
1/8 of an
Yes.
inch container.
So if we came into this tank after years of inspection, and I would see half of it gone here, I already had that problem. These are indications that I probably hundreds of spots, maybe thousands of spots, Mike.
Yes, and we've already located a spot within this tank underneath the manway. It's actually leaking down through the floor and out. That's how we discovered that we had a leak in this tank, and we put it out of service. But when you start seeing a number of these, you probably do have thousands of them. And so we made a decision with this container that it was no longer economical to continue to try to repair and use it.
Okay. Well, Mike, I think we've seen everything we needed to see in here. It gives us a real good visual for those of us that are visually oriented, and then we have something to back us up in terms of it's just not a guesswork, but we have a half of this is eaten. Half of this.
There are probably multiple places
Yes.
that were greater than 50% on this tank.
Well,
It's not pretty.
no, but now it shouldn't be.
But I think after the years of service, it's been moved a time or two. It's probably paid its bills.
You betcha. All right, well, let's get out of here, Mike, and go on back outside
All right.
and keep looking over at these tanks.
Thank you, Fred.
You bet.
Doc, great opportunity to have a chance to see you working with and looking some tanks in the field. Helps us to get an example of what we need to be looking for when we have tanks that we inspect. Heck, we might have come on to an operation and we don't remember when that tank was put in place. All the more reason to know the product that you're using. And we're trying to avoid an event that looks like this.
That's correct. That's not what you want to wake up to. And people say, what's the big deal? Well, you've lost chemical, right? I mean, you've got downtime. You've got environmental problems, you've got reporting problems, you've got government fines, you've got government sanctions, you've got the bad PR that you get in the community. So there's nothing wrong with mild steel, but if we know that rust and corrosion is the issue, then that's why we want to spend some time occasionally inspecting them. So if a tank is going bad, then we could budget for a new tank.
Or have the opportunity to make a repair that would prevent for a problem further down the line.
Yes.
But we do have two different types of tanks that we're talking about here. We've talked about mild steel. There's the prettier one, the stainless steel that we can talk about.
That's correct. And the stainless steel, which you see almost universal, has to do with our transfer tanks. When we take a load of product out to a sprayer, for instance, or to a farmer's place, and we unload it. The advantage of stainless is it's less likely to rust and have rust flakes. And so that I'm not putting it into an expensive sprayer and plugging everything up with rust and pieces of rust. It's a cleaner product and much easier to clean. And so we can have a transport tank, or we can have a upright storage tank. So either way it works. Advantages: less rust. Obviously the disadvantage of stainless is
the price.
the price. You pay for it, okay? And so again, you can see easy to maintain, long lasting, some of the same things as the mild steel, limited rusting, corrosion. I can paint them, repair them, they seep. I can get them really thoroughly clean. And in today's market, with a lot of our products,
Exactly.
being able to clean them well prevents me having problems with wrong residues on wrong crops. And sometimes I can add a lot more mechanical agitation to them. It supports it. So the key thing, though, with all of this is probably today is the cleaning, and it's also less limited rust and corrosion. Now, disadvantage, expensive, and we've got to know the grades of stainless. And to get over this mindset that they're totally corrosion free, that's not true, but they're less likely. All right, now, might seem obvious to people, but maybe I'm just a little bit slow.
You can paint them both, so if you walk up to a tank, how do you know whether it's mild steel or whether it's stainless steel?
And I'm sure there's people out there that can look at it and say one way or the other, I don't know. So what I always bring, I got a magnet here, and I throw that magnet. If it sticks, I know then it's mild steel. And if it doesn't stick, I know it's stainless.
So stainless is good, but it's not indestructible.
No, it's not. It comes pretty close, except that it's got its issues just like mild steel has. Good things that happen. Again, the reason they're clean, I can get it in limited rust, but there's also an issue of how these things are mounted on trucks. But let's focus now on the stainless. Notice that I have grades here. With stainless steel, we usually use the 300 series in ag. There's a 304, which is commonly what we use. It's pretty good for all of our fertilizers, chemicals, fuels, gas. It's very, very good. Now, if we have some things that are very, very acidic, we will go to the 316. So anytime that we're going to buy a stainless tank, we want to make sure what we're going to put in it. Ask the manufacturer, will your stainless hold up to this?
Very important when you're speccing the product.
When you're speccing the product
that
out.
you're going to bring in and
Yes.
introduce to the operation.
And again, we do the 304, it's cheaper. This is just a, what do you call it? It's more processing, and they're going to get rid of some of the stuff that could corrode a little bit more.
And you'll get what you pay for.
You get what you pay for.
But as with any tank, it has to be secured.
That's correct. Now, we're going to focus on the transport tanks. And if you notice right here, can you see what they've done with this one?
They've got rubber belting under the steel bands that are holding it in place.
Because one of the things we know about these on trucks, that these things can bend. All right? And so anytime I put pressure on them, I'm trying to protect it against this band here. This was one of my growers that actually did it, and you can see here what they've done. Can you see the black tubing?
They're using chain and they're using it inside black tubing,
Yeah.
and it's secured and looks like that's doing a good job of taking care of that
In
tank.
fact, they're doing multiple things here. You can also see straps that are being put on, there. Now, the key here, one of the downsides of stainless on trucks is this ability of this right here. You'll see this one.
Spring tensioning, if you will.
Yes. So imagine if your truck comes off the side wheels and your frame of your everything's bending like it should. What would happen to this tank if it didn't have the ability to flex?
Something's got to give.
Something's got to give. And so I'm going to use this Coke can here as my example. If I take it and I go like this, and you can see here what happens, can't you?
You can see the force and the way it just
Yes.
it spread across the radius of the
And
of the
these
can.
tanks will do the same thing. This is why it takes a lot of effort to be able to mount these up properly, so that if this thing's ever in a flex, it has room to give without bending, okay, which weakens it. And probably the last one that doesn't happen very often, but it's kind of and it's kind of funny actually, but
Okay.
it's
unless you're writing the check to replace
that's
it.
correct. So you know that any of these pumps, you have so many gallons, right, that you can pump out of it. And it's like any container. If there's not enough air to replace it, you're sucking it down. And so in this case here, what they did was they were pumping out more than the air was filling it, and so they just sucked it down.
But it's strapped really nice, but it's been up
Yeah.
and
And so now we have a weakened spot there, right? So stainless has got maybe less problems, but you're going to pay for it. But there are some things that we have to do. So, Jeff, what I thought we would do, let's go back to the field and look at some stainless tanks, and let's just kind of, put our arms around stainless for a few minutes. Mark, good to see you.
Nice to see you too.
Thanks again for coming out here at the Co-Alliance plant. And Mark, before we start talking about stainless steel, maybe give me something about yourself. Or, what's your history?
Well, I've worked for Murray Equipment for 35 years, selling pumping and metering and tanks and other equipment.
You betcha. Good deal. So lots of experience. There's a perception out in the industry that, I spend the money for a stainless, spend good money, that these things are going to last forever, no maintenance. How would you argue with that, or would you argue with that after 30-something years in the business?
Well, I wouldn't argue with it, but there are some cases where stainless is broken down or fatigued over time, and there's also some corrosion from materials that aren't compatible with stainless.
Okay, so let's just sort of back up then. When you say corrosion, I'm thinking of rust as an example. You too?
Correct.
Okay. Now, we are under the impression that stainless doesn't rust, but are you seeing some rust here, though it's not bad? Stainless can rust, can it?
It does rust. Generally speaking, it's a white rust, similar to the dust you'd see off galvanized.
Okay.
Okay, that's the coating coming off. In this case, the metal will rust, and
Would you wipe? Is that what you were showing us with your hand?
there's a little bit of rust in this stainless right here because there's still just a small amount of carbon steel left in 304 stainless.
Okay.
This isn't hurting anything, but the misconception of it doesn't rust is inaccurate. It does rust.
Okay, so this is you were talking about
9% carbon free.
carbon free, and carbon is one of those things that rust.
That's the red rust you see from alloy steel tanks from iron steel.
And so this is a 304, and it does fairly well for everything that we put in. So pesticides, fertilizers, what other kind of products would we be? I mean, that's the two.
That's basically what we put
Okay.
in
So
stainless in the ag industry.
this is perfect for that, right?
Yes.
But there are some that we have to be real careful about, mindful about doing, putting them in these tanks, because in fact it's corrosive to the tank.
There are a handful of herbicides that require a different grade stainless, and there are some plant food materials in their production form, phos acid, for example, that require 316 stainless as opposed to 304 stainless.
So that 316 stainless is the step up that we use in ag.
That's correct.
So you mentioned a bunch of them. You had what some of the micronutrients? What were some of those?
Well, if you've ammoniated boron, iron, zinc, manganese, magnesium,
Okay.
calcium, for example, those are made with an acid to make them into the micronutrient, and they are corrosive in some degree to stainless.
Okay, so out here we're going to be looking for rust, and we see some. This is a brand new tank. I
That's
wouldn't
correct.
expect to see, this is a 2018 tank, so I'm not expecting to see a lot. But anywhere that I could scratch it, as we said, I could take a key here or a screwdriver, scratch it, and right there in a week or two, I could see some rust on the surface.
You'll see a small amount of red, the little bit of iron that's in there will show up, yes.
So when we go inside of this tank, just like we just did a few minutes ago with the mild still tank, when I go inside of a tank that's been up for a number of years, what would you expect to see?
Inside the tank, you should see it being basically clean as far as the wall surface will be clean. There could be some scouring or scabbing similar to what you saw inside the iron tank. It will scab and flake some stainless off if it's reacting with it.
Okay, so similar to what we saw in the mild steel.
Yes, similar.
Wrong material in this tank, that's where we're going to see this.
That's correct.
So if we were doing an inspection, maintenance of a stainless tank, what would be some critical things that you would like for the industry folks to do, whether it's a daily inspection like we do here at this facility, or whatever the scheduling of maintenance is at a plant? What would you like to do on stainless?
Well, I think basically you look at the tank physically to make sure there's no leakage or seeping from weld points.
Because this is something that we do. This is a weld that we put in, right? And if my weld is not done properly, or it's broken down or whatever, that might not be all from corrosion, right?
That's correct.
Could be a quality control.
That's correct.
It could be anything. Okay, what else would we look at?
You want to look obviously at where your appurtenances fit in, your valves and your hardware, your manway, to make sure there's no leakage or seepage around
Okay.
that or the manway gasket. And then the other thing you're going to look at is for physical damage. Example would be if the tank wasn't vented properly and you pulled material from it, it could pull
Okay.
the walls in and you could damage the tank.
Okay, so there's 2 or 3 things there. And how about going inside? Is there anything that you would do? We talked a little bit about it, but if I went inside this one, same things I do with mild steel?
Absolutely.
Okay. When is it that a tank maybe it's a question that doesn't have an answer. How do I know when this tank is done? It seemed like it was pretty easy on the mild steel. It seemed like it's going to be more difficult on a stainless.
Well, I think you could still look at doing the mic test to see what the thickness of the metal is if there has been scouring or scabbing from the inside.
Okay.
And then obviously overall appearance, if you start to have welds break down or structural cracks along the weld lines, then you just have to use the same basic system of how
Right.
long the life of this tank, how much life this tank has
So really
left.
not a whole lot of difference.
No.
Now, how about you suggest that we actually go into these tanks every so many years? I mean, I'm looking behind you here. This kind of down low where we're filling up here. Would you want me to go in here and wash it down any? Does that offer much when it comes to stainless?
I don't really think washing it down is going to do much good, but you do get some settling in the tanks that need to be cleaned out, whether it's a stainless tank or a
Okay,
steel
same
tank.
thing.
So it's the same.
Okay, so basically outside of it's a lot of visual inspections, specifically welds and other places. That's the primary focus on the maintenance.
Yes.
Okay, well, very good. Appreciate your expertise, sir.
Thank you.
Fred, what a neat opportunity here in a video series like this. Number one, to talk about things that we need to be aware of, but also to be able to go to the field and look at things firsthand and then come back and then discuss them. Obviously, we have product that we use. It's critical in agriculture today, but we have to maintain the product and the integrity of that product. And there's no indestructible tank, and we've learned today that you just can't assume that tank is going to be good forever, whatever it's made of.
You betcha. And that's the point. It could be poly, fiberglass, mild steel, stainless steel. They all got their benefits, they all got their negatives, and we have to work on those negatives to get them out of our system. And so the idea here is like anything we have at the retail store, everything requires a little maintenance. And this is a visual maintenance and just making sure that these tanks hold up and we don't have to deal with the problems that's created when we ignore them and assume they're going to last forever.
Well, it's a pleasure with the Legacy series to talk about things and how you can prevent accidents and do a better job of maintaining your operation and serving your customer. This series is called It's a Pitting Shame. For Dr. Fred Whitford, I'm Jeff Nally for the Legacy series.